Oh, okay, recording. Yes, raining. Phooey. Shucks. Darn it. Anyway, make a video anyway. Hope the rain noise isn't too oppressive. And if it is, well, then we'll just have to say too bad. Anyway, yeah, using a different camera. See how this one works. I actually bought another one of these. It's not a very good camera, but you know, it came with a 2 GB SD card. And so, you know, I only paid like $8 for the camera to take out the $7 for the card. Anyway, this is totally irrelevant. So, yeah, I sort of attempted to waterproof this thing, but I probably should have put more tape over it. Anyway, but who cares? Anyway, this little screen is broken anyway. Anyway, video. Alright, two thoughts I was having. First one was just on the subtle differences between, you know, what makes somebody great at something, you know, the best in the world, and, you know, the second best, or whatever. It's just these little bits of knowledge, you know, just little bits of understanding, little bits of skill, like say race car driving, for example. You know, a guy knows just a couple extra tricks, you know, that makes the difference between, you know, millionaire, great life, blah blah blah, and, you know, being some guy who isn't any of those things, doesn't have a great life, and, you know, is sort of a failure. You know, it's just so stupid when you think about it, because it's just, you know, obviously there's so much of this that could probably be imparted from one person to another, but we're sort of, you know, protective of our little bits of talent and superiority, and so we'll kind of like keep our secrets, so to speak, you know, and when we have them, we tend to anyway. I mean, obviously some people are pretty comfortable and secure, and they don't mind, you know, giving it away, so to speak, which is very nice. But anyway, ooh, what was that? Something. Anyway, so the point was, this also got me thinking. So now I'm going to do it like a draft science video. Pyro might like this conversation, I don't know. I was thinking about light and the speed of light and all that crap again. And this idea that, okay, you can't impart more speed onto light. So if I'm walking this direction, the light emitting from me can't go faster because I'm moving. But what can happen is that the frequency of the light being emitted from me can be changed by my movement. So if I'm moving fast enough, kind of like that train effect, you know, as the train's coming towards you, the pitch is higher. Train going away from you, the pitch is lower. The same thing happens to light, because the photons I'll be emitting, or be reflecting, I will gain on them a little bit as I'm walking. So the first one I emit is now over there, out there somewhere, forward of me, and I've caught up on it just a little bit. I've stolen a little bit of its distance by moving forward in the same direction. And so now the next emission from me will have imparted on it that little slight change in the distance, relatively speaking, between the photons, and that we could call frequency. So that's a particle theory of light, is that the frequency is decided or dictated by the distance between the events. And to me that makes sense. That describes the circumstance. But what is tricky, and what part that just got me running this through my head, was how the mechanics of the filters are created. Because like substances are opaque to ultraviolet light, and yet will be transparent to infrared light, like glass. And then you'd have like crystal would be the other way around. Ultraviolet go through fairly easy, infrared not so good. And so I mean, it's a weird circumstance. Like, how exactly is the matter reacting to a frequency to create something like opaqueness? Let's say the particle's coming. When the single particle's coming, holy crap, this is a lot of rain. Oh man, jeez. I better check the cellars. Whoa. Doesn't feel like that much rain. But man, that's a river. I don't know if I can cross that without getting, wet. But I'm dressed to get wet, so it's probably okay. I just have to find a suitable spot, I suppose. Ooh, muddy. I'm down here. I might as well finish this. But man, that's a lot of water. Whoop, a lot of water. Alright, so back to the filtering thing. I better talk louder because of the water making all this fucking noise. Never mind. This video's got fail written all over it. Okay, anyway. And this camera, I mean, shit, it goes through 2 gigabytes like it's nothing. I think I'll get, 10 minutes. Anyway. Alright, so this whole idea that somehow this filtering takes place, that somehow surfaces, or our eyes, for example, can distinguish between this stream of photons that's coming at us and say, yes, that's yellow, or that's blue, or that's infrared or ultraviolet or whatever it might be, and somehow it's doing that. And that's a very curious circumstance. I mean, how exactly does the dumb, stupid particles, how are they able to create such a filter? Presuming that all the photons are the same, and the only way they can make the distinction is by how often they're arriving. Oh man, I don't know. Well, what the hell, right? Just gotta save my e-cigarette. Gotta hit my sock here. Alright, see what happens. I am walking in the water now. Whoa. God, there's a lot of fucking water. I am really surprised. It really didn't seem like that much rain. Look how muddy it is. Holy shit. So anyway, it really didn't seem like that much rain. Alright, so I was going to go for a run. But we don't know if that's going to happen. Anyway, continuing where I left off. Yeah, so how's it doing this filtering? How is it detecting the difference? Not even detecting, but through what physical process does this take place? And it seems that something must be created, like some sort of force, some sort of thing happens. Like say if you have 2 streams, infrared and ultraviolet, heading for a piece of glass. Now the ultraviolet will just bounce off. It'll just say, what the hell is this? This is hard as a rock. And the infrared will just shoot right through. Now, why? What happens when those particles hit at a certain frequency? So something must be vibrating. Something must, the first initial impact, the first particle hits, there's only a certain amount of time that some sort of process takes place where, and if there's not enough time, the way isn't cleared. So I sort of thought about this as I was thinking about that racetrack scenario, the car drivers and how there's so little difference. And I'm thinking about, when they're going through a crash or something, that, it's the dynamic, and so there's some sort of dynamic that takes place where you're almost better off going faster if you want to get through than going slower. As stupid as that might sound intuitively, yeah, you're better off to get through it really quick because less can take place, less can happen to you. The slower you go, the more likely something is to jump in front of you. So apparently something's happening when electrons come in faster, that creates something that just makes it impossible. They just somehow, they can't get through. But they can get through if they're coming in just slow enough. They're going through the turnstile. Maybe turnstile is a good way to put it. Like they can only get through if they come at a regular speed. But if they come too fast, they back up on each other. They clog.